Welcome back, everyone. So let's continue exploring some interesting classes that Java libraries already have for us. These are going to be both interesting for our learning, from our learning perspective, and they're going to be useful down the road when we will become software engineers. One of these classes is going to be our math class. So let's demo some methods of our math class. To do so, let's continue our tradition of creating new packages and naming them by our sections. So right-click on your source folder and hover over New Package, click, and we will call this package, we will name this package section 2_2. Finish. Within this package, we'll right-click on the name and create a new class called Math.demo. And always pay attention to your naming conventions. Finish. Eclipse has created a class for us. It has defined its location already. Perfect. So let's create our main method, public static void main string array of arguments of our space. Now we said math class is one of those classes that is located in that java.lang package. So we do not need to import it. Okay, and please pause this video and remember which other classes that we have seen so far are also located in java.lang. Great. Now let's create a couple of variables. Int number 1. Let's continue our tradition of giving this number a value of 5, and int number 2, we're going to assign it a value of 3. Correct? Now, what we're going to do, we're going to look at a few math class methods. Okay? Now, one of the simplest ones is going to math dot. We're going to look for max. Open parentheses. When you do so, Eclipse already creates the signature of the method for you, and it tells you that you can enter number 1, that's it defines as A, and you can enter number 2. So let's continue by what Eclipse does. So what we're going to do, instead of A, since it's highlighted, we're going to continue typing number 1 and then hit comma, and Eclipse will automatically highlight B for you. And here we're going to type number 2. Close parentheses, finish your statement, okay, by using semicolon. So right now, when I run this program, nothing is going to happen. Because what happens here, nothing is going to happen on the console. But what happened in the background, if you put yourself in the shoes of a compiler, is that compiler came here, found out that we're declaring and assigning a new int variable called number 1 with the value of 5, came to line 8, so that we're declaring and assigning int variable called number 2 with the value of 3, came right here, it called the Math.max method, and it took number 1, which has the value of 5, and it took number 2, which has a value of 3. It found out what the highest number amongst these two is, right? But it didn't do nothing to it. It just returned it, but where? Nowhere. So nothing happened. So to see something on your console, you need to take this method and put it in your print line or in your print statement. Okay, so you see what I did? I took a print statement, correct? A print line method. And within this print line method, instead of adding a variable or anything, I just put the whole math method itself, correct? Now, when I run this, it will print out 5. Because what will happen is the compiler is going to come to line 7, declare a variable, come to line 8, declare a variable, come to line 11, and when it starts going through line 11, it will see that there is a print statement, and within a print statement, there is another method that it needs to take care of first. So it takes care of this method. This method returns 5 because Math.max returns the highest number of 2 numbers within this method, 2 values or 2 parameters within this method that are passed into this method. So we're going to start talking Java now. So what Math.max does is takes the two parameters that are passed into the method and finds whichever is the highest and returns it. In this case, number 1 is the highest. Number 1 is greater than number 2, and it returns it. It returns it to here, and from here it is being printed. So print, and these are our comments. Highest of 5 or 3, which is equal to 5, correct? So it prints 5. Awesome. So we saw what Math.max does, and we saw how we could print it out. Now we're going to look at Math.min, and you can probably guess that Math.min is going to look at the minimum of the two numbers or the least of the two numbers, correct? Now in this case, instead of printing out right on the same single line, what we're going to do, we're going to create a new variable in smallest, and we're going to say this is equal to Math.min of these two numbers, right? And then we're going to take the smallest and print it in a more professional way. Smallest of the two, and we're going to say plus smallest. Now when we run this program, when we execute this code, it will keep printing 5 because we did not change anything until line 11. And it will come to line 13, create a new variable, and assign this variable the outcome, the output, or the return value of Math.min class. I'm sorry, Math.min method, where one of our numbers is 5, one of our numbers is 2 that we passed in as an argument, as a value, and then between 5 and 3, we have 3 as the smallest. And this is what we're going to print out. When you run this, it's going to print 5 from line 11, and it's going to come to line 14. It's going to print smallest of the two, 3. Awesome. Okay. Now there is one more math class, math method. I'm sorry, I keep saying math class. There is one more math method that we will find useful. This is going to be useful in finding distances between 2 points, and this is going to be math.absolute. What Math.absolute does is, if you look at Eclipse, it will say right here, it returns the absolute value of a double value, or we're going to click on int, it will say returns the absolute value of an int value. If the argument is not negative, the argument is returned. If the argument is negative, the negation of the argument is returned. So if we pass in a negative number, it will return its absolute value. An absolute value of negative 58 is 58. Now you're gonna say that what is the point of using absolute? This is going to be used in examples where we will need to find distance between two numbers. So in mathematics, you know that the distance between negative 3 and 5 is equal to negative 3 minus 5. This is equal to negative 8. And if we put it in absolute value, the distance is always an absolute value. It is 8, right? So how do you understand this? You understand it from this point of view. You have, let's say this is your line, right? This is your mathematical line. In this line, you have negative 3 point, that is here at this point, negative 2, negative 1, 0, 1, 2, 3, 4, 5. So from negative 3 to 5, how many points? What is the distance between negative 3 and 5? How many points did it pass? So this is point 0. At negative 2, we have 1. At negative 1, we have 2, 3, 4, 5, 6, 7, 8. So distance between negative 3 and 5 is 8. Distance between 3 and 5 is 1, 2. Correct? So that's where absolute helps us. So if you're given a task to find a distance between, between 2 points given as numeric values, you're going to use Math.absolute. Okay? So if I say system out print line, the distance between number 1 and number 2, and I say math absolute, find absolute value of number 1 minus number 2, and let me close the parentheses for print line method. And when I run it, it will print out the distance between number 1 and number 2 is 2. If I change number 1 to a -5, or let's keep it -5, correct? So what is the distance between -5 and 3? Is going to be still 8, correct? So distance between number 1 and number 2 is 8. The smallest of the two, these outputs have already changed. The smallest of the two is -5, and the largest and the biggest of the two is 3, if we change the variables, okay? Now, there are other methods. We saw max, we saw min, we saw absolute value, why we might need to use it. Now let's look at operations with taking one number to the power of another number, okay? Let's say int to the power is equal to, we're gonna call Math.pow, short for power. It takes in two numbers, correct? It will take in two, it will allow us to take to pass in two arguments. Now we're going to pass in number 1 as argument 1, and we're going to pass in number 2 as argument 2, or parameter 2. It's going to give us an issue. It's going to highlight an error for us. It says cannot convert from double to int. So power, So power, math.power returns a double value. This is a key thing. This method returns a double value. You cannot assign it to an int variable. Remember our early lessons about assigning the same type of an variable to a new declared variable. So instead of int to the power, we have to declare this variable to be of double, right? The type of this variable has to be double for this return value to be able to get assigned to it. Okay, now let's do this. Now system out print line number 1 to the power of number 2, because we're taking number 1 and increasing to the power of number 2 is going to be whatever the assigned value of to the power variable. So basically number 1 is -5, to the power of 3 is going to be 25 minus 125. If I'm not mistaken, if my math is correct. Perfect. Number 1 to the power of number 2 is -125. Now, if we switch places of number 1 and number 2, what will happen is, let's put number 2 here and number 1 here. Now, number 2, which is 3, is going to be raised to the power of -5. Now, the answer is not going to be 125. When you run it, it's going to be, oh my God, whatever, right? I'm not going to read this number out. So basically what happens when you use math.power method is that the first number is going to be raised to the number of to the power of the second number. You can put here any number you want to instead of your variable. So you can say, for an example, 2 to the power of 2 is going to be 4.0, because this is returning a double. 2 to the power of 3 is going to be 8, correct? So we said integer is 4 bytes. 4 bytes means there are 32 bits, so which means maximum integer value can be 2 to the power of 32. Run it. This is going to be 4 point, and E9 means you're going to add 9 zeros to the back. 1, 2, 3, 1, 2, 3, 1, 3. So it's going to be 4,294,294,000,000, etc., etc. So how we find the highest positive value? We divide this by 2, right? Or you can say 2 to the power of 16. This is going to give you the maximum positive value of an an integer. Oh, I'm sorry, 2 to the power of not 16. It's going to be, yeah, I believe 32 to the power of 30. 31, 2 to the power of 31, yes, 31. So this is going to return you the maximum positive value of an integer, 2,147,483, blah, 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 okay? So this is what Math.pow does. The opposite of Math.pow is square root. Math.sqrt square root of, for example, 4. Here you pass in one number and it just takes the square root of it. Gets you the square root of it, right? System out print line square root of 4 is equal and plus concatenate square root variable. Run this program. This will return us 2. Perfect. Now there might be cases when you want to create random numbers. So to create random numbers, Math class provides an interesting random solution for you. Now this random solution is interesting because this here returns numbers from 0.0 to up to 1. So 0.0 is included, 1 is not included. So basically this returns any kind of a double number between 0.0 and 1. Now you're gonna say, how can you make a use of it, right? Let's create double random 100, right? Is equal to Math.random. So what I'm gonna do is I'm gonna show you how to get a random number between 0 and 100. What you're going to do is you're going to take this output, multiply it by 100, because this is going to return you up to 1.0, right? So it's going to be anything between 0.0 up to 1.0. When I run this, let's see what happens. First time, okay, oh, I didn't print it, nothing happened. So let me print it to the console, random 100, run it. It gave me 26.81, okay, and blah, 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 blah. Next time I run it, it's never going to give me 26.81 and that again, because every single time it's going to give me a random number. Now it gave me 5. If I run it again, it gave me 70 point something. If I run it again, it gave me 17 point something. So every single time it's going to give me something, right? Whole number and the floating point. So how do I get rid of that floating point? There is a method called Math.round. So this Math.random method accepts a double or a float argument, and it returns a long, correct? So what I can do to get a random number to the whole point is I can take this method above, Math.random times 100, copy it, paste it within this method. Let me open some space, right? Close your statement and assign its value to a long variable, long random number. Random, let's call it this way, whole 100. So now we have here random 100, which has floating point numbers, and random whole 100 is not going to get me the floating point numbers. It's going to use Math.round method, which takes a double value, which takes a floating point value and converts it into a single or a whole numeric value of type long. So when I print this out, system out print lane, we're going to say rounded up random plus random whole 100. When you run it, there is some kind of a there is something that I'm missing here. What are we missing here? Why did it print 94? Hold on. If you have figured out why this printed out 94, you've been paying very close attention. Because what happens is every time you call Math.random, right? Every time you call random method, it creates a random number. The problem we ran into here is we called random number here. It gave us 18 point something, right? Then we called random method again on a different line. So this random number returned on line 30 is not the same as this random number returned on line 34. So if we want to work with the same number that was returned on line 30, we cannot do this, because this is going to return a new number. So what we're going to do is we're going to take this random 100 variable and put it here. So random 100. And now when we run it, what will happen is this is going to return us 8.72, correct? And this is the number assigned to random 100 variable. This is the value assigned to random 100. And when we come to line 34, and when we round up 8.72 blah blah blah, what happens is that's rounded up to number 9. So that's how you can get a rounded up random number. Let's run this program one more time. 10.1107 etc. is rounded down to 10, right? When you run it one more time, 12.27 is rounded down to 12. Run it one more time. 37.89 is rounded to 30, rounded up to 38. Perfect. Now that we have seen a few a few math class methods, you know how to find the math class itself from our previous video. We know where to find Java libraries. We know where the java.lang package is hidden. We know where math class is within. So feel free to go ahead and explore the methods inside. However, don't spend too much time on that. We will see math class methods as we proceed further in our course. The best thing to do is just Google most commonly used math methods in Java, and you will find a list of 20-30 commonly used math methods that you might need to be aware that they exist. Well, thank you very much. In our next video, we will look at more options, and we will look at we will look into how we can use multiple methods on a single line. I already started giving you an example by adding Math.max and Math.min methods within system.out.println method, right? So in the next video, we will specifically look into nesting methods. Thank you very much for your time. I will see you then.